This is Baalbek in the Lebanon. Each of these 3 blocks weighs 900 tons.
Deep in Lebanon stands a platform of stones so huge and precise that even modern engineers struggle to explain how they were moved.
It was the view, very firm view of archaeologists, that there had been no megalithic architecture. When I say megalithic, I mean literally big stones, stone circles, huge constructions, nothing like that before 6,000 years ago.
Recent AI analysis, new quarry discoveries, and fresh damage from ongoing conflict now reveal clues that overturn everything we thought we knew about Baalbek. From forgotten megablocks to hidden layers of ancient construction, the mystery is bigger and stranger than ever imagined. Are we finally close to the truth? Let's discover. A city of stones too big to believe. It's a single block of stone so heavy it outweighs 10 blue whales, carved and moved long before machines, long before steel, and long before modern cranes. At Baalbek, in the Bekaa Valley, 3 stones, known as the Trilithon, each weigh around 800 tons, and nearby in the quarry lies an unfinished block estimated at 1,500 tons. These numbers are so far beyond anything most ancient builders even attempted that they force 3 shocking questions. Who first decided to cut stones of this size? How could they possibly move them? And why would anyone try to do something that seems impossible? Baalbek sits in the Bekaa Valley, a wide, fertile corridor between 2 mountain ranges that for thousands of years has been one of the most important east-west routes in the ancient world. This valley linked the coastal ports of the Mediterranean to the inland cities of Syria and Mesopotamia, which meant that whoever controlled it controlled trade, food supplies, and the movement of armies and ideas. It is no accident that one of the largest religious complexes on Earth was built right here, in a place where people have lived for more than 9,000 years. The location alone helps explain why generation after generation kept returning to build, demolish, and rebuild on the very same ground. The ruins that dominate the site today belong to the Roman Temple of Jupiter, once the grandest temple in the Roman Empire. To grasp its scale, remember that even Rome itself never built anything quite like it. The massive podium, or platform, that supports the temple was extraordinary even by Roman standards. What makes Baalbek truly unique, however, is the presence of those gigantic foundation blocks, the Trilithon, fitted together with such precision that not even a thin blade can slide between them. And there is more. In the quarry nearby rest 3 even larger unfinished giants, the famous Stone of the Pregnant Woman, the Stone of the South, and the most recent discovery called the Forgotten Stone. These unfinished blocks show that whoever was cutting them had a clear plan to use stones of unimaginable size, even though some were never moved. To put this in perspective, modern heavy-lift cranes, the type used in massive shipyards, are usually designed for loads under 1,200 tons. The idea that an ancient culture could shape and move something even heavier challenges everything we think we know about ancient engineering. Yet the story of Baalbek is much older than the Romans. Archaeologists digging beneath the massive foundations have uncovered traces of human presence reaching back to the Neolithic period, which means people were living and building here about 9,000 years ago, long before the Romans, long before the Persians, and even before the Phoenicians who left their own mark on the region. The timeline unfolds like a series of overlapping layers. First, Neolithic villagers, then Phoenician religious builders, followed by Hellenistic craftsmen after the campaigns of Alexander, and finally the Romans, who launched their most ambitious construction phase in the 1st century of the Common Era. By the Byzantine period, the site was converted for Christian use, its temples adapted or dismantled to create churches. Later Islamic dynasties reused the structures and turned parts of the complex into fortifications. Each era added or removed pieces, leaving a puzzle where the deeper archaeologists dig, the more complicated the origins become. Recognition of Baalbek's exceptional status goes back decades. In the year 1984, the United Nations Educational, Scientific, and Cultural Organization declared it a World Heritage Monument, highlighting both its global significance and the urgent need for protection. But long before UNESCO, European travelers and scholars in the 19th century were already stunned by the scale of the stones. German, French, and later Lebanese archaeologists spent decades studying not just the temples, but also the mystery of the foundation blocks. Each new excavation either narrows the possible explanations or opens even more questions, keeping the mystery alive after more than a century of research. The dimensions of these stones are absolutely baffling to hear. The largest unfinished block in the quarry measures about 19.5 meters long, 6 meters wide, and 5.5 meters high, with an estimated weight of about 1,500 tons. Imagine stacking 4 fully loaded passenger airplanes, or trying to move a diesel submarine across rough ground without wheels, steel cables, or hydraulic machines. How could any ancient society cut, shape, and attempt to move something so enormous with only the tools of their time? This is the heart of the mystery, and the reason why modern researchers, now using high-resolution scans and artificial intelligence models, are still trying to uncover the real methods behind this extraordinary construction. Threats, new quarry finds, and the weight problem. No one solved. In 2014, archaeologists in Lebanon announced a discovery so staggering that it instantly rewrote everything researchers thought they knew about Baalbek. While exploring the ancient quarry that supplied the stones for the Great Temple platform, a joint team from the German Archaeological Institute and the Lebanese Directorate General of Antiquities uncovered a colossal block of limestone that had been hiding in plain sight. Buried beneath centuries of soil and debris, this newly identified monolith, quickly nicknamed the Forgotten Stone, is even larger than the famous stone of the pregnant woman that lies beside it. Measuring roughly 19.5 meters in length, 6 meters in width, and 5.5 meters in height, it is estimated to weigh an almost unimaginable 1,500 tons. To put that in perspective, this single stone is heavier than 2 fully loaded Boeing 747 airplanes combined. The shocking implication is that the builders of Baalbek were not only capable of moving stones that already seemed impossibly large, but were preparing to move stones even bigger. Why would an ancient culture attempt something that even 21st century construction equipment would struggle to achieve? The circumstances of the discovery make the story even more dramatic. The team was not expecting to find anything new of this magnitude. Excavations in the quarry had already revealed the stone of the pregnant woman, itself weighing roughly 1,000 tons, and the slightly larger stone of the south, but the Forgotten Stone was completely hidden beneath layers of rubble. When ground tests revealed a massive solid object, researchers carefully cleared the overburden only to realize that an even larger block of perfectly squared limestone lay beneath. The precision of the cut surfaces shows that the ancient quarry workers were not simply rough cutting the stone, but carefully shaping it for transport and installation. This single discovery proves that the quarrying operations at Baalbek were more ambitious and better organized than anyone had previously believed. And it raises a disturbing question. If such stones were prepared but never moved, what technology or method did the builders intend to use, and why was the work suddenly abandoned? The discovery of the Forgotten Stone built on a decade of groundbreaking research that had already begun to change how archaeologists understood Baalbek. In 2004, a joint project between the Lebanese University and the German Archaeological Institute launched a detailed mapping and analysis of the quarries surrounding the site. For generations, scholars assumed that the massive trilithon stones of the temple platform came from a small ridge directly above the temple, which would have minimized the distance of transport. The 2004 survey shattered that assumption by proving that the true sources were large quarry pits located several hundred meters away, at a lower elevation. Using geological sampling, ground-penetrating radar, and careful analysis of tool marks, the team demonstrated that the ancient builders extracted the giant blocks from a variety of quarry beds and then hauled them uphill to the construction site. This finding meant that the challenge was not just carving the stones, but moving them across uneven terrain and lifting them into position. A feat that becomes even more daunting when you imagine dragging a stone as heavy as a small warship up a slope without modern machinery. These discoveries might sound like the stuff of ancient history, but Baalbek is not a sealed time capsule. It is a living site located in a region that remains politically fragile, and recent events have shown just how quickly irreplaceable evidence can be lost. In early 2024, a series of airstrikes near the Bekaa Valley caused shockwaves that damaged several Ottoman-era structures close to the Baalbek complex. While the Roman and earlier foundations are built from stone massive enough to withstand tremors, the surrounding historical layers, including later buildings, inscriptions, and smaller artifacts, are far more vulnerable. Archaeologists warn that every impact, even if it does not directly strike the main temples, risks destabilizing soil layers, breaking fragile masonry, and erasing subtle clues about how the site evolved over thousands of years. The danger is not limited to the stones themselves. When layers of soil are disturbed, the context of artifacts, exactly where and how they were found, is often lost forever, making it impossible to reconstruct the sequence of construction and reuse that is key to solving the Baalbek mystery. The urgency is clear. The discovery of the forgotten stone proves that Baalbek still holds secrets underground. But conflict threatens to destroy those secrets before they can be studied. Archaeological research depends on context. The precise position of each tool mark, each chip of stone, each fragment of pottery tells a story. If those fragile details are blasted apart, no technology, not even the most advanced artificial intelligence, can recreate the lost information. This is why international heritage organizations have called for stronger protective measures, digital documentation, and emergency funding to safeguard Baalbek and its surrounding quarries. Every year of delay increases the risk that future generations will inherit only questions and broken fragments rather than answers. The combination of the 2004 Quarry mapping and the 2014 Discovery Forces experts to reconsider every assumption about the site. If ancient builders were quarrying and planning to move stones that push the limits of modern engineering, how much skill and planning did they truly possess? Were these massive blocks abandoned because of technical failure, a sudden political change, or an environmental disaster that made the project impossible? Could the builders have used methods now lost to history, or were they simply relying on brute force and ingenious but forgotten engineering techniques? Each of these questions becomes more urgent when modern conflict threatens to erase the very evidence needed to answer them. Unless action is taken to protect the quarries and the wider complex, the answers to some of humanity's greatest engineering mysteries may be lost in our own lifetime. Archaeology and chronology. Who was here and when? When people first encounter the gigantic stones of Baalbek, It is easy to assume that the site must belong to a single lost civilization, but the real story, revealed by more than a century of excavation, is far more layered and far more interesting. The first systematic attempt to study Baalbek came in the year 1898, when German Emperor Kaiser Wilhelm II sponsored an expedition to survey and photograph the ruins in unprecedented detail. This early team carefully documented the Roman temples and began clearing centuries of debris, but their methods were limited by the technology of the time. During the early 20th century, French and Lebanese archaeologists expanded the work, cataloging inscriptions and collecting small finds such as pottery shards, coins, and carved architectural fragments. Excavations paused during periods of political upheaval, especially during Lebanon's long civil war from 1975 to 1990. But in the last 3 decades, a new wave of international projects has resumed digging with modern techniques such as laser scanning, ground-penetrating radar, and microstratigraphic soil analysis, revealing details that the first explorers could never have imagined. One of the most striking results of these modern excavations is the discovery of Neolithic occupation layers beneath the later Roman and Hellenistic structures. These layers contain stone tools, animal bones, and simple pottery that date back as far as 9,000 years ago, showing that humans were living on this plateau long before any temples were built. But living on a site is not the same as building megalithic platforms, and this distinction is crucial. Archaeologists use the term occupation to mean that people left evidence of daily activities such as hearths, food remains, or small shelters. Construction, by contrast, refers to deliberate, large-scale building. The Neolithic finds prove that humans were present and active at Baalbek very early. But they do not prove that these earliest inhabitants had anything to do with the colossal stone podiums or the Roman temples we see today. Dating each layer of Baalbek's history relies on methods that may sound technical but are easy to understand once explained. Stratigraphy is the basic principle that deeper layers are older, as long as the soil has not been disturbed. Pottery typology compares the style, shape, and decoration of ceramic fragments to other well-dated sites, creating a relative timeline. Architectural style also plays a role, since Roman column designs or masonry techniques can be matched to other buildings of known age. Radiocarbon dating of organic materials such as charcoal or bone provides absolute dates in some cases, but these tests are only possible when suitable material is recovered. By combining these approaches, archaeologists can build a sequence of human activity even when written records are missing or incomplete. The Roman phase of Baalbek is the most visually spectacular and best documented. Beginning in the 1st century BCE and continuing for more than 200 years, Roman engineers erected the grand temples of Jupiter, Bacchus, and Venus, along with courtyards, staircases, and monumental gateways. Inscriptions and coins link these works to specific emperors such as Augustus and Antoninus Pius. Yet even during the Roman period, the builders were working with a site that already contained massive stone foundations. Beneath the Temple of Jupiter lies a podium of enormous limestone blocks known as the Trilithon, and many scholars believe this platform predates Roman construction. The Romans clearly recognized the advantage of such a massive base and incorporated it into their own design, reinforcing it with additional walls and columns. This reuse of older structures was common throughout the ancient world and should not be confused with mystery. When Roman architects encountered a strong foundation, they often built directly upon it rather than starting from scratch. The absence of detailed Roman accounts describing how the largest stones were transported is sometimes presented as proof that the Romans could not have been responsible. But history is rarely so simple. Ancient texts are notoriously uneven. Roman authors were far more interested in political events, military campaigns, and religious ceremonies than in the mundane details of quarrying or hauling stone. Many records that might have mentioned engineering techniques have also been lost over the centuries through fires, wars, and the decay of fragile manuscripts. The silence of surviving texts, therefore, cannot be taken as evidence of a lost civilization. It is equally plausible that Roman engineers simply left no written explanation because their methods were standard practice for them, even if those methods now seem extraordinary to us. After the decline of the Roman Empire, Baalbek continued to evolve. In the late 4th and 5th centuries CE, Christian communities converted parts of the complex into churches, adding mosaics and altering altars to fit their liturgy. During the early Islamic period, the site became a fortress and a center of regional administration, leaving behind Arabic inscriptions and modifications to the defensive walls. Each of these layers adds complexity to the archaeological record, creating a palimpsest of cultures that must be carefully disentangled. Could an earlier unknown civilization still lie beneath the deepest Roman foundations, waiting to be discovered? That question drives ongoing excavations, but current evidence shows a long sequence of human occupation rather than a single mysterious builder. By carefully reading the soil, the artifacts, and the architecture, archaeologists can figure out how site grew from a Neolithic settlement to one of the most ambitious temple complexes of the Roman world. The mystery is not whether humans were capable of shaping Baalbek, but how many different societies contributed to the monumental puzzle we see today. The engineering puzzle. How impossible is impossible? When archaeologists talk about Baalbek as one of the most perplexing sites on Earth, what they really mean is that the engineering math pushes the boundaries of what we know ancient builders could achieve. The Romans certainly had tools, and in some contexts we can reconstruct their techniques with great confidence. They used treadwheel cranes, massive wooden wheels that men walked inside like hamsters to wind ropes and lift blocks, capstans powered by teams of workers or animals to pull loads, and pulley systems to multiply force. Surviving records suggest that a single treadwheel crane could lift stones weighing between 2.5 to 6 tons. In extraordinary cases, with multiple cranes working together, perhaps up to 50 tons could be managed. Those are impressive numbers, but when you compare them to a block weighing 1,000 tons, you see the staggering gap. A crane designed for 6 tons would have to be scaled up nearly 200 times in capacity to handle one of Baalbek's largest monoliths, a leap that strains credibility given the limits of timber strength and rope technology. So how did ancient builders move heavier stones elsewhere? And could those methods apply here? Experimental archaeologists have tried multiple approaches. In the 1990s, a Japanese team successfully moved a block weighing more than 100 tons using sledges dragged over wooden rollers. Later experiments used tracks lubricated with water, oil, or even olive residue to reduce friction, cutting the force required almost in half. Earthen ramps have also been reconstructed to show how stones could be dragged uphill incrementally, with soil piled behind to prevent sliding back. Each of these methods works for blocks in the range of 100 to 300 tons, and in some cases, slightly more. They prove that with enough workers, ropes, and patience, immense stones can indeed be shifted. The difficulty is that the trilithon stones at Baalbek weigh more than 4 times the upper limits achieved in these experiments, and they were not simply laid at ground level, but raised onto a platform roughly 7 meters, or about 23 feet, above the surrounding terrain. To understand the scale of this problem, let's walk through the numbers. A single trilithon block is estimated at around 800 tons. 1 ton equals 2,000 pounds. So this means one block weighs about 1,600,000 pounds. If friction could be reduced so that each worker only had to pull 50 pounds, you would still need 32,000 workers pulling in perfect unison to move just one stone. That number is not impossible in an empire as vast as Rome, but the logistics of feeding, housing, and coordinating such a labor force in a confined space raise serious questions. And the challenge was not just horizontal movement. The builders had to elevate the block by 7 meters. If they used a straight earthen ramp with a gentle slope of 1 in 10, the ramp would have to stretch 70 meters in length. For stability, the base of that ramp would need to be several meters wide, meaning tens of thousands of cubic meters of earth moved just to prepare for each stone. Even if we accept that ramps could provide the needed elevation, the placement of the blocks still astonishes. The 3 trilithon stones are not only massive, but also fitted with millimeter precision against one another, leaving no gaps. Engineers today use laser-guided equipment to achieve that kind of tight join, yet at Baalbek, these fits were achieved with hand tools. To move a block weighing 800 tons into position and then nudge it with enough control to align perfectly with its neighbors requires force applied with surgical accuracy. One miscalculation, and the block would wedge incorrectly or crack under uneven stress. How could ancient builders maintain such control without steel machinery, hydraulic presses, or modern surveying instruments? The physics also become mind-bending when you think about lifting rather than dragging. Raising a 1,000-ton block vertically, even by a few centimeters, would require ropes and supports strong enough to hold forces of millions of pounds. Timber beams begin to fail under loads far lighter than this, and natural fiber ropes can only withstand so much tension before snapping. Could the builders have used counterweights, levers, or sand-filled pits to achieve incremental lifts? Each theory has been tested in small-scale experiments, but scaling them up to Baalbek's dimensions pushes beyond what has been physically demonstrated. This is why, even after more than a century of study, Baalbek's trilithon remains a puzzle that refuses to be fully solved. We know that ancient people were ingenious, and we know they were capable of feats that often surprise us. We have seen how ramps, sledges, and brute manpower can move extraordinary weights. But when we run the arithmetic, when we add up the tons, the laborers, the ramp lengths, and the precision required, we arrive at numbers that make even hardened engineers pause. Could the Romans really have coordinated a project on such a scale? Or does Baalbek still hide an engineering method that has slipped through the cracks of recorded history? That is the question that keeps researchers returning, and it is the question that makes Baalbek's platform still feel almost impossible today. The quarry evidence, where the stones came from. If the sheer size of Baalbek's stones makes the mind reel, the nearby quarries provide an equally astonishing but more down-to-earth key to understanding how those stones were prepared. Less than a few hundred meters southwest of the main temple complex lies Hajar al-Hibla, a sprawling limestone quarry that sits slightly higher in elevation than the platform itself. That small difference matters a great deal. Because the quarry floor is above or roughly level with the construction site, any blocks cut there could be slid or rolled downhill or along gently sloping ramps rather than hauled upward. This single geographic fact immediately changes the problem from a nearly impossible lift to a difficult but conceivable horizontal transport. And it is one reason why archaeologists are confident that the stones were moved with human methods, not supernatural ones. Walking through the quarry today feels like stepping into a half-finished ancient construction yard. 3 gigantic blocks dominate the scene. The most famous is the so-called Stone of the Pregnant Woman, measuring about 21 meters long, 4.5 meters high, feet and 5 meters wide, with a weight estimated at roughly 1,000 tons. Nearby lies the slightly larger Stone of the South, and beneath layers of soil, researchers uncovered the still larger Forgotten Stone in 2014, a block estimated to weigh around 1,500 tons. Each of these stones remains attached to the bedrock at one side, revealing that quarry workers cut channels along the bottom and sides before attempting to detach the final face. Clear tool marks are still visible. Parallel chisel lines, wedge holes, and shallow grooves that show where ancient masons inserted wooden or metal shims to separate the stone. These marks are not mysterious. They are exactly what one would expect from large-scale but methodical hand quarrying. Why were these megablocks left unfinished? Detailed examination provides practical answers. The stone of the pregnant woman contains natural fissures that could have caused dangerous cracking during transport. The Forgotten Stone shows slight irregularities in density that may have made it unstable. Abandoning a flawed block was a rational choice, because a break during movement would waste enormous labor and risk injury. Other explanations include changes in construction plans or political upheaval that halted work. Whatever the reason, the stones freeze in place, a snapshot of the quarrying process at the moment it stopped, allowing modern researchers to study the exact sequence of cuts and to calculate the forces involved. A major breakthrough in understanding this process came from the 2004 project jointly run by the Lebanese University and the German Archaeological Institute. Using modern surveying instruments, the team produced the first high-resolution topographic and stratigraphic maps of the quarry and its relationship to the temple platform. They documented channels where blocks had been removed, identified ancient ramp traces, and measured the subtle downhill gradient that would have aided transport. Geological sampling confirmed that the limestone of the quarry matches the trilithon blocks exactly, leaving little doubt that the stones were cut on site rather than brought from some distant mystery location. The researchers also found smaller cut blocks and unfinished channels, showing that quarrying was carried out in stages and that workers likely extracted multiple blocks simultaneously to manage workflow. These findings undermine the idea that the giant stones were moved by unknown forces. Instead, they reveal a pragmatic and organized operation. Quarry workers first outlined a block by cutting deep trenches on 3 sides, leaving the bottom attached. They then drove wooden wedges into the cuts and soaked them with water, so that expanding wood would slowly separate the stone from the bedrock. Once freed, the block could be placed on sledges or rollers and guided along prepared paths toward the building site. Because the quarry sits slightly higher, gravity itself would help initiate movement, though the sheer mass still required teams of workers and careful control. This method is consistent with techniques documented in Roman engineering texts and with evidence from other ancient quarries across the Mediterranean. The quarry also helps explain why some blocks appear larger than those actually used in the temple platform. Ancient builders often prepared oversized stones to ensure sufficient material for final dressing and to hedge against unexpected flaws. If a stone proved too flawed or too heavy to move safely, it was abandoned where it lay, rather than risk catastrophic failure. The presence of these abandoned giants therefore tells us more about the practical limits of ancient construction than about any lost technology. Thanks for watching. If you enjoyed this, don't forget to like, comment, and subscribe. Click the next video for more exciting content.